Our lesson for today will be looking at Chemistry 1502. The topic for today is formal charge. This is lesson 101. Let us start. Formal charge is very important, especially when it comes to organic chemistry, where we have to draw resonance structures. Remember that the resonance structures are structures which are a bit different, but they are representing one compound. So in order for you to know how to determine the most stable structure for that particular compound, you need to calculate the formal charge. So in order to calculate the formal charge, you need a Lewis dot diagram where you know the basics of how to draw a Lewis dot diagram, and also the basics of the properties of each and every element that we have within that particular compound. So the equation to calculate formal charge is Fc, which stands for formal charge. It's equals to valence electron of that particular element minus a lone pairs minus half of bonded electrons. So you just need to know how to draw the Lewis dot diagram in order to see the valence electrons. The valence electrons, by the way, you can simply find them from the periodic table or watch the basics of chemistry. You'll know how to determine the valence electrons. You should know how to indicate the lone pairs and also the bonded pairs. Now in this lesson video, it will depend on the length of the lesson video. If we have enough time, we'll go up to 10 examples, but I can guarantee you that we'll be doing about 5 of them. Then if we have enough time, like I said, we'll go up to 10. So the first formal charge we'll be looking at is for elements in H2O. The first thing that we need to do, let us draw the Lewis dot diagram. We know that we have single bonds and we have lone pairs. So calculating the formal charge of each and every element here, let us start with hydrogen. Formal charge of hydrogen, it's equals to, we know that hydrogen is from group number 1, so its valence electron is 1, minus, it doesn't have any lone pairs, 0, minus half of bonded electrons, we have 2. Remember that one line we have 2 electrons, so here we are going to have 2. This will be 1 minus 0, 2 multiplied by half, 2 multiplied by negative half will get negative 1. Then you can see that this will result into 0. Since this hydrogen is identical to this one, it simply means that this one will have formal charge of 0 and also this one formal charge of 0. Now let us go ahead and calculate the formal charge of oxygen, which will be FO. It's equals to, we know that the valence electron of oxygen is 6, it's from group number 6, minus lone pairs, it is 1, 2, 3, 4. So we have 4 here, minus half of, we have 1, 2, 3, 4, we have 4 here. So the formal charge of oxygen is equals to 6 minus 4, then this will give us negative 2. So you can see that the formal charge of oxygen here is also 0. The reason why this compound is not a polyatomic ion, or that those particular compounds which have plus minus here, a charge here, is that the sum of all the formal charges will give you the overall of the oxidation number of that particular compound. So you can see 0 plus 0 plus 0, it will simply give you 0. That is why this particular compound is neutral. Let us look at the second example. You can see that this is a polyatomic ion. Now with the formal charge, it will actually tell us where this comes from. So let us draw the Lewis dot diagram of this. We have something like this. With lone pair and so calculating the formal charge. By the way, this video is directly linked to the Lewis dot diagram lesson 5.2, where it shows how ions are formed, or how to draw Lewis dot diagram of ions, polyatomic ions. So the formal charge of hydrogen in this case, let me do this. Hydrogen, it's equals to valence electrons is 1, there's no lone pairs, 0, minus bonded, half of bonded is 2. So you can see that formal charge of each and every hydrogen we have here, it will be 0. So we have 0, 0, and 0. Now we can go ahead and calculate the formal charge of oxygen. We know that it's from group number 6, minus lone pairs, we only have 2 in this case, minus half the bonded, we have 6. So you can see that we have 6 minus 2 minus 3, and then this will give us 6 minus 5, which is equals to positive 1. So it means that the formal charge of oxygen here is positive 1. So you can see that the sum of all these formal charges, 0 plus 0 plus 0 plus 1, it will give us the overall charge. That is why we put this inside a bracket, and then we simply remove this charge here, then we put it here. This 1 plus, it comes from the formal charge of oxygen. Now to review the lesson 5.2 of Lewis dot diagram, we said that oxygen, it will bond 2 times. Once it bonds 2 times with 2 atoms, it will have 4 lone pairs, or 2 lone pairs which consist of 4 electrons. If it bonds with 1 atom, it will form double bond with that particular atom and have 2 lone pairs. And then we further said, if somehow oxygen bonds 3 times, it will have lone pair, and then it will yield a positive charge. This is what is actually happening here. We are proving this theory of lesson 5.2 using a formal charge. And then we further said, if oxygen bonds only once, it will have 3 lone pairs, which consist of 6 electrons and a negative charge. Should it happen that we look at an example whereby oxygen bonds only once with 6 lone pairs, you will see that its formal charge will be 1 minus. Now for this one, you can pause the video and play the video to verify your answer. Now what you should know is that NH4 is a polyatomic ion. It means that it has a charge here, but I'm not going to give you a charge right away. The question would be, figure out what is the charge of NH4. So the first thing that we have to do, we know that nitrogen will be the central atom. Then we go ahead and calculate the formal charge. Now we can see that hydrogen is still the same as the previous example, so we can safely say the formal charge of hydrogen in this case is 0. Now let us go ahead and calculate the formal charge of nitrogen. The formal charge of nitrogen is in group number 5, it has 5 valence electrons, minus, you can see here it doesn't have any lone pairs, minus half bonded is 2, 4, 6, 8. So we have 5 minus 0 minus 4, then we can see that 5 minus 0 minus 4 is positive 1. So the formal charge of nitrogen here is positive 1. So it simply means that the charge of NH4 is 1 plus. To review again, lesson 5.2 of Lewis dot diagram, we said that nitrogen, it bonds 3 times. If it bonds with 3 elements, it bonds using single bonds, and then it will have a lone pair. And then if it bonds with 2, we are going to have something like this, still maintain its lone pairs. If it bonds with only 1, we're going to have something like this and still have our lone pair. So in simple terms, you can see that nitrogen, it bonds 3 times, having lone pair. Now if it happens that it bonds 4 times like this, it will yield a positive charge. By the way, this explanation is covered in 5.2. So it's either it can be like this, just know it will have a positive charge as long as it bonds 4 times, or it can be like this, or it can be like this if it is possible, or it can be like this. Just know that it will have a positive charge. And then if it bonds only 2 times, just know that it will have 2 lone pairs, and then it will yield a negative charge. So you can see that when it yields a positive charge, it doesn't have any lone pairs. We can prove that using a formal charge. Let us look at this. Now you can see that we have a negative charge here. So let us go ahead and draw the Lewis dot diagram. Remember that this needs to bond only 3 times, and then it has lone pairs here. Then the lone pairs for this one is this one. And then for oxygen, since it bonded only once, it will have 6 lone pairs. Now by just looking at this, we can see that this cannot have any plus minus because it has reached its octet state with 3 bonded and 1 lone pair. Also this one you can see as a divalence electron, divalence atom, bonded 2 times and with 2 lone pairs. And then this one you can see that it only bonds once and 6 lone pairs. So you can clearly see that this will be a -1, but we can prove using formal charge. Formal charge of nitrogen in this case, 5 minus 2 minus half of 6. Then you can see that we have 5 minus 2 minus 3. This will give us 0. And then the formal charge for this one, the first oxygen, we are going to have 6 minus 4 minus half of 4. So we have 6 minus 4 minus 2, which will give us 0. So we have 0, 0, and for this one, the second one, the formal charge of the second, which is 6 minus lone pairs, it has 6, minus half of bonded, it only has 2. So you can see that this will get rid of this. Then we have -half multiplied by 2, it's -1. So you can clearly see that this negative, it comes from the second oxygen. And by the way, there is another way to draw a Lewis dot diagram of this, by just taking this double bond and bringing it here, and then this will yield a negative charge. And then we say this is the second structure of this, which is the resonance structure. But like I said, resonance structure will be covered in the next lesson. Let us look at our last example. There will be a lesson video whereby we look at practice questions of formal charge, where we'll be looking at more examples. So to draw this, we have 3 different types of resonance structures, but we're just going to cover one, and then the rest we'll leave it for the next lesson video based on resonance structures. Now if we try to accommodate nitrogen and write it like this, so that it has reached its octet state with lone pair, we know for sure that we are going to have lone pairs here. This will be negative. This will also be negative. This will also be negative. Now looking at the sum of this, you can see that it doesn't add up to this. Remember that we only need 1 minus, but negative 1 minus 1 minus 1, it will give us negative 3, which this is not the correct Lewis structure for this compound, polyatomic ion. So what happens if we can just take these electrons and then we bring them here, such that we have something like this. Negative. This one will also still have a negative charge. Now remember that when nitrogen bonds 4 times, it becomes positive. So in this case, let us check. We have negative 1 minus 1 is negative 2, plus 1, it will give us negative 1. So we are safe to say this is one of the Lewis structure of this polyatomic ion. Now to calculate the formal charge, this one, as you can see, it obeys all the octet rule, or it has reached the octet rule, so you can say the formal charge will be 0. And then by just looking at this, definitely sure the formal charge will be negative 1. Then looking at this one also, the formal charge will be negative 1. I hope this color is visible. And then the formal charge lastly for nitrogen will definitely be positive 1. So this is how we calculate the formal charge of elements within polyatomic ions and compounds. In the next lesson video, we'll be looking at practice questions and also do the resonance structures. That's it for this lesson video. This is Wakula SJ. Thank you very much.